protective shell and crawled along the ocean floor. Unfortunately, having a protective shell makes species evolve very slowly. For example, turtles have stayed virtually unchanged for millions of years. But about 140 million years ago, something went wrong, and these creatures evolved to be shellless. With a soft and defenseless body and no camouflage, clumsy octopus ancestors had very slim chances of survival. This was the moment of truth. Either cephalopods became easy prey for predators and completely die out, or start developing faster and more creatively. As you can see, the cephalopods decided to fight for life and radically rebuilt their anatomy. And what they did turned out to be incredibly efficient and completely outside the box. Firstly, the octopi turned their soft and almost amorphous body into a strength, not a weakness. Since the octopus has almost no firm parts except for the beak, it can crawl into any hole, if it's at least a millimeter wider than its eyeball or beak. This allows the octopus to hide in very narrow crevices, which is a powerful evolutionary advantage for escaping large predators, such as sharks or dolphins. Second, octopi have evolved an even smarter way of staying unnoticed. In fact, they're one of the best animals on the planet to disguise themselves. Notice how quickly and unexpectedly it changes color. And not only color, but also texture, that is, patterns. And not only texture, but also their body surface configuration. Changes occur instantly or in stages as the octopus merges with the environment. The animal instantly becomes indistinguishable from a group of algae, coral, sand, stone, or anything else. We've seen this only in sci-fi movies, but at the same time, here it is. What is this guy doing? Does it follow any laws of nature at all? And how is this even possible? Yes, it's really hard to understand. Cephalopod camouflage relies on a system of extremely complex tissues. Chromatophores are scattered throughout the octopus's skin. These are tiny sacs filled with pigment. They densely cover the skin like freckles. The chromatophores can have black, red, or yellow pigment. The sacs are surrounded by radial muscles that can stretch the container, thereby revealing the pigment color. Depending on which sets of chromatophores the octopus opens or closes, it can create stripes, spots, and design entire patterns, instantly becoming indistinguishable from nearby objects or the background. You might think, black, red, and yellow. But what about other colors? For this, the octopus uses a whole different mechanism, which is even cooler. There is a whole layer of highly unusual thin cells that grow in a kind of stacks in the octopus's transparent skin. These are iridophores, which are located directly below the chromatophore layer. And unlike chromatophores, they don't contain pigment, but rather special proteins called reflectins. Their unique property is being able to reflect only certain light wavelengths. It is thanks to iridophores that the octopus can turn into unreal shades of metallic blue and green. But that's not all. Under the iridophore layer, there's another layer with other natural reflectors called leucophores. They reflect the entire spectrum, thereby creating a white color. By combining reflections from iridophores and leucophores with the correct pattern of chromatophores, an octopus can quite convincingly recreate its surroundings. But even that's not all of it. The octopus's camouflage arsenal has a real combo that virtually allows it to disappear from sight altogether. Its skin has another structure, a network of papillae that can change the skin texture, creating rising and falling ridges and bumps. So the octopus imitates not only the color and pattern of the surroundings, but even the surface configuration. Do you spot an octopus here? I don't see it either. Nobody does. And yet, it's in front of us. With all these tools, the soft-bodied, shell-less octopus has been fooling oceanic predators for millions of years. But octopi rely on more than just their camouflage to survive. The way they manage their body is an even more effective survival tool. When octopi travel across the sea floor, they have to constantly register the background to change their camouflage accordingly. They are lightning fast at making decisions. Observations have shown that an octopus can change its camouflage 177 times an hour. And the octopus's camouflage reaction speed is up to 200 milliseconds, which is faster than that of any other animal. To put this in perspective, it takes about 20 seconds for a chameleon to completely change its color. Considering how fast the octopus reacts to its surroundings, and the accuracy of reproducing colors, patterns, and shapes, one naturally comes to wonder whether this guy has amazing eyesight. How does it manage to see so well and distinguish colors so accurately with a pair of regular eyes? And here comes an even bigger surprise. The octopus generally can't distinguish colors with its eyes at all. It's completely colorblind. Oh my God, what? How is this possible? How can it reproduce the colors that it can't even accurately see? Just recently, scientists started to research this question. Detailed studies conducted in 2015 showed some convincing results. Researchers discovered that octopus skin is sensitive to light due to photoreceptor genes in the skin. Even when the skin is separated from the body, it can react to light and change the shape of chromatophores. Scientists have realized that an octopus can see not only with its eyes, but also with its skin.
Fucking cool.
One can only wonder how the sense of sight is processed by the octopus's brain and consciousness. Hold on, did I just say octopus consciousness? Did I say it out loud? Well, I'll have to explain what I mean. Moreover, this is perhaps the most amazing thing about octopuses, even cooler than their camouflaging talents. But first, let's start with their nervous system. We take for granted our centralized hierarchical nervous system. However, the octopus convincingly proves that everything can be completely different. Imagine that in addition to the contents of the skull, each of your arms and legs has a brain of its own. And these 4 brains are totally independent of the central nervous system and can make their own decisions. Feet go wherever they please. Hands grab whatever they want. For real, they literally do whatever they please. Can you imagine what it is like to think with 5 brains? How will the most diverse impulses be managed within such a complex physiological structure? What part will be responsible for your consciousness? Maybe there are 5 personalities living in such an organism at once. It makes for a good Hollywood movie, but the reality is much more thrilling than any movie. We somehow can get used to the fact that an octopus has 3 hearts. There's one major heart that pumps blood throughout the whole body. The other 2 are specialized to pump blood only through the gills.
You can trust Royale bathroom tissue for quality and softness, but did you know it's carbon neutral? The Royale brand is part of an organization that plants millions of trees each year in responsibly managed forests. Royale, trusted quality, carbon neutral.
Hey, I'm Richard, and yeah, I'm hungry. Thanks to Good Food and their no food waste mission, I haven't had a decent scrap in months. It all started when Good Food's planet-saving meals with their perfectly portioned ingredients started showing up everywhere. I mean, what's a raccoon supposed to eat around here? Gooder? It's not even a word.
I use it all the time.
But how do you
Because
like the fact
good
that
isn't
each of
good
its
sometimes.
tentacles also has a separate mini-brain? And this is no exaggeration. These
Okay,
nerve
boy.
clusters can make decisions completely independently. If you cut off the poor fellow's tentacle, it will continue to react to the environment, run away from threats, and try to grab potential prey. The octopus's nervous system isn't concentrated in
You
the
all
brain,
have a
which serves
wonderful
as a
day.
centralized organ of analysis and control.